Hi there, we have started to do a review for tomorrow's exam on statistics. And we are starting out with a histogram. And I'm gonna fess up, I forgot to turn the recording on. So I'll bring the rest of you up to speed. We're gonna draw a histogram. I gave you some data. So we have, this is a frequency table, by the way, this thing. I have my intervals here. I have my frequency there. And we have started by drawing the horizontal axis, and this was minutes, and I should have had that written here. Okay, frequency up that way, nice title over there. Hey Harmony, what am I gonna draw?
The bars?
Yeah, as I'm doing that, I'm going, I don't know how to get you. In a real world, in a normal COVID world, I would say, go up to the board and do this. But the first frequency was 5, so I'm going to find 5, and I'm going to connect it with 10, and scribble it in. And then we're going to have 7. All right, you guys finish it off. And ta-da. You guys give me a thumbs up to say, yes, I can do this tomorrow. Come on, Shadow, find the electronic one. All right, cool. Excellent. Essentially it's a bar chart, except I learned when I started teaching this section, a bar chart has spaces between the bars where the histogram doesn't. Okay, so that is the histogram. If we want to make it into a frequency polygon, it's super easy. Michelle, do you remember how to do that?
No.
Okay. Anybody remember? Okay, I do. So what you do is you put a dot in the middle of each of your bars, like that, and then you connect them. So we can connect from 0 to there, 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 and technically you go to about there, halfway towards the next one. The textbook goes into a really long explanation of how you can draw a frequency polygon without drawing the histogram first, but I think it's a waste of time. I'd rather just draw my happy little histogram and then connect it. If you have one set of data, a histogram is fine. If you're trying to do 2 sets of data at the same time, then a frequency polygon is easier because you just have 2 sets of bar or 2 sets like this. Oops, hold on. Right? There's one data, and maybe these are Joanne's Zoom calls. And then we might do a second set of data as Brian's. And if we tried to draw those as funky little bars, they'd be covering each other up. It doesn't work well. So a frequency polygon is really good when you're doing more than one set of data at the time. All right, that's all I want to say about that stuff. So bye-bye. Get our list. So we just did that, we did that, We did that. All right, explain what standard deviation means. Standard deviation is how spread out the data is. That's the simplest explanation. Okay, there's your symbol for standard deviation. Again, spread of the data. Whoops. If you have a big sigma, is equal to a big spread. So for example, if we looked at the ages of students in a grade 12 class, if we were talking about high school kids, the standard deviation would be really small, because in grade 12, you might have kids maybe 16 to 19, maybe-ish, right? It's gonna be pretty, our data's gonna be pretty close together. Whereas if we looked at the standard deviation of this class, I don't even know who the youngest is, 19, 20, and then there's me on the other end, right? So people in their 40s, it's gonna be way more spread out. So the standard deviation for our class would be bigger. I don't know if we talked about consistency, but it's the same idea. If your standard deviation is low, it's very consistent. So if I show up every day at 7:30, between 7:30 and 7:35, that's going to have a really low standard deviation. If we talk to somebody else who shows up somewhere between 7 and 9 for school to work here, then they're going to have a bigger one. Let's do some examples. Morning. All right. Brian says hi. He'll see you later. That's okay. Check it out. We got it on the big screen and nobody but you here to watch. What are we going to talk about? You know what? I'm just going to use marks. So the mean math mark, if I took the average of class right now, I have no idea. So I'm going to say it is 68% with a standard deviation of 3%. I would like you guys to draw the curve for me. Draw and label the curve. I think on the test you have to do it at least twice for marks. And I think there's another question where it's like, do it, don't do it, but I'm not giving you marks for it. But if you're lost, always good. I'm gonna pause the video for recording. This should be boring by now. In the real world, the chances of your mean being in a whole number and your standard deviation being a whole number are pretty slim. But it just makes it faster for us. 0.15, 2.35, 13.5, 34, 4. Whoa! 13.5, 0.15. All right, so we got 68 plus 3 would be 71, 74, 77, 65, 62, 59. Did I get my numbers right? Give me a thumbs up. Okay, cool. All right. Oh, wait a minute. This would be percent. And this would be math marks. This would be frequency. So looking for 3 labels on them. Let's start with simple. What percent of the class has a mark over 71%? B under no, under 9%. All right, Shadow, who has, how many, bleh, I'm gonna try again. What percent of the class has a mark over 71%?
I add the 13.5, 2.3 and the 0.15.
Mm-hmm.
Oh, I didn't add it together.
Okay, but you know what to do, and that's cool. And you get 16%, by the way.
Okay.
And on your exam tomorrow, you will have the percents and stuff. I give you the one picture. All right, Renee, how about under 59%? Or sorry, Rena, my bad.
Um, 0.15%.
Yep, I gave you an easy one. There we go. All right, Harmony, how about the one that's between?
83.9.
They disappeared. So from 65, ooh, it's gonna overlap. What did you say it was, Harmony?
83.9.
Not that I don't trust you, but I better show my work. 34 plus 34 plus 13.5 plus 2.35. Did you get it right? The rest of you? The number's just making me weird. It doesn't sound familiar to me.
83.85.
Oh, okay. That sounds more familiar. Don't round. I don't think I mark it wrong or anything, but just for tomorrow. 68 plus 13.5 plus 2.35. There we go. 83.85. Sweet. Okay, so that's straightforward. If we want to get more interesting, well, we'll keep on this. Never mind. What percent under 60%? Michelle, what's the problem with 60%?
That the number's not on the bottom,
Right, so what are we gonna have to use?
the table.
Yes. And what else?
And I don't know.
The Z score to get to the table, but
Oh,
you're
yes,
right.
the start to score to get to the table.
Okay. So 60. I'm gonna say 60 is about there. So I know it's not very much. And like 1%. I like to estimate, but I notice that drives students nuts. So that's just my guess. So we're gonna, when you don't have the number you want is not across the bottom, you need to use a Z score. So Z is X minus mu over sigma. All right, I'm gonna stop for a sec and let you guys do that. I'm also gonna find my Z score table. All right, so we got a Z score. So the X is my data point, so that's gonna be 60 minus my mean. Goodness, what was my mean? My mean was 68 over my standard deviation, which was 3. So Z score is gonna be minus 8 over 3, and I'm gonna go up here so you can actually see what I'm doing. So 8 divided by 3. Negative 2.67. So when you divide that out, always, this is the point where you round to 2 decimal places because that's how your graph is gonna work. And this is standard deviations. Now, before I mess around with the table, I want to see if I'm right. So we got negative 2.67. So there is negative 1 standard deviation, negative 2 standard deviations, and some more. So that's a reasonable answer. Most common mistake is a sign, so be careful on that. So then we get our handy dandy Z-score table. And I need negative 2.67. So I look up negative 2.6. So negative 2.67. So first 2 numbers come from this row, this column. And then I need 7 as my last number. So I don't know if you guys can see it, but it's 0.0038. So I'm going to take this away. And I always write that part just so I know, or someone else knows where this is coming from. I need to do one last thing. Who can tell me what I need to do yet?
You need to change it from a decimal.
And how do I do that?
500.
3 times the 400.
Woohoo! So 0.1238%. Well, that seems really small because I was guessing 1, but I know for sure it better be bigger than 0.15, and we got 0.38. I'm going to call it close enough. I'm going to save us some time. Okay. You guys give me a thumbs up if you're happy with that. Got this? Awesome. I was going to do a separate question, but we're just going to reuse this one. What if I wanted to know what percent of the class was over 60%?
Would you just minus that from 100, like the answer we just got?
Yeah, I was going to do a separate question, but why? So yeah, just be careful. Every time you use your handy dandy Z-score table, it's always giving you this tail. It's always giving you the amount that is left of the graph. So if you need the stuff, if you need more, then you just subtract. So you would just go 100% minus 0.38. I don't know, 99 point something or other. Minus 0.38. 99.62%. So the hint there is just watch for whether it says over or under. All right, I'm gonna go back to my list. How far have we got? Explain the shape of a normal curve. Yeah, we drew a normal curve. Don't worry about the skewed and bimodal and stuff like that. We did it, we're not using it. Sorry, going through the list. Yeah, we're pretty much golden. All right, so just thinking of the questions on the test tomorrow. What if, oh, the population pyramid, right? That thing I had up a little while ago. The blue one, I turned it on its side. Is this a normal, let me see that, there we go. A normal distribution, yes or no? Anybody want to answer? Nobody wants to answer. No, it's not. A normal distribution has to start out small and get bigger and bigger and then go like that. It doesn't work for those population pyramids. Well, frankly, because this was 0 years. These were the babies. There's nobody that's negative age. Just a hint for the exam tomorrow. Okay. The only other questions are the ones we were doing at the end. Let me try and make one up on the fly. I'm going to use a warranty question because it's just the easiest. The mean. manufacturer. Okay, so I'm going to pause the recording. All right, I'm back. Let's take a look at this sucker. Well, truth be told, I see mean and I see standard deviation. The moment I see that, I am, honestly, I'm kind of lazy or I'm pig-headed. I don't know what the right word is. But first thing I'm going to do is I'm going to draw my chart, because actually the word I was searching for is I'm a visual learner. So, ta-da. I'm going to do the chart. So 4.8 plus 0.6. All right, so 4.8 plus 0.6 is 5.4 plus 0.6 is 6. I'm embarrassed I did that. And this would be 6.6. And this would be years. And then I'm going to subtract. So 4.8 minus 0.6, 4.2 minus 0.6. I like your music. Minus 0.6 should be 3. All right. We got our years, we got our frequency. And we got cell phone, nope, calculator life. All right, now I can read the rest of the question. If a manufacturer is willing to replace 5% of the calculators, how long should the warranty be? Whoops, I forgot my percents. I keep doing that. 13.5, 2.35, 0.15. Okay, so if this is a 10-mark question, right now I've probably got, I don't know, I'm going to guess like 3 marks. So even if you're going, oh no, it's one of those warranty questions, I don't know how to do this, you can do this. The next thing we want to do is figure out where the 5% is. People are showing up. Good morning, Brad. And hold on.
Good morning.
I saw Rachel a minute ago, and now she's disappeared. All right. Anyway, so you got some marks there. Let's see if we can figure out the replacement. And the way I always think about it is, if I went to the mean and I said, I'm going to replace anything that dies before or breaks down before 4.8 years, I'd be replacing 50% of the calculators. That's way too much. So if I go down to here, I'm replacing less and less and less. Or maybe you want to go, maybe it makes more sense to go the other direction. If I go this way, I'm replacing 0.15%. If I go to here, if we add those up, who knows what the total is? Shout it out of these two. How much is that?
2.5.
2.5%. Well, my manufacturer is going to be generous. We want more than that, but we can't add on this entire extra section because that would be, well, I don't know, but it's going to be way more than 5%. So somewhere here, and I'm just randomly making it there, is the spot where this part that I just colored in blue is 5%. So I want this blue part to be 5%. So I know my answer is going to be somewhere between 3.6 years and 4.2 years. You're probably at 5 out of 10 by now. And if that's what you write for an answer, somewhere between that and that, you know what? That's not bad. That's half right. But the fact that we're not matching up with any of those numbers tells us, gives us a hint of where we need to go next. And what is that? Anybody?
We have to get the Z-score.
Yeah. Somewhere in here, we're going to use a Z-score. Anytime it's not the numbers across the bottom, there's going to be a Z-score involved. And I'm actually ahead of myself because there is a step first. So I'm going to put Z-score over here. X minus mu over sigma. We have to deal with that 5%. All right, Mr. Brad, how do I convert 5% into a decimal?
You divide it or
By what? Whoopsies.
100?
Yes. It's going to be 0.05. Yes. And then, what do we need next? Anybody? Z-score. But when the question gives you a percent and you have to work back to get your number, you're going to look for 0.05 in the boxes. Oh. Okay. Now, this one's silly. You look on our Z-score. Sorry about the movement there. Maybe that's supposed to refocus. There we go. All right. So the number we need is exactly in the middle. I will, if you use this number, I'll mark it right. If you use that number, I'll mark it right. It doesn't matter to me because with 5%, we're really in there. So just for today, I'm going to say we're going to use that one because this one technically is a teeny bit over 5%. But I'd be okay if you used it. So 0.495. So from my table, and I just messed that up, 0.0495, because I need to figure out what that is as a Z-score. So I'm going to highlight my row, and I'm going to highlight my column. So my first two numbers are going to come from here. So this is a Z-score of negative 1.6. Right, that's from there. And then I get my last decimal place from up there. So it's going to be negative 1.65. And now I'm going to move the camera again. Sorry, making a mess today. Okay, so now that I have that handy dandy number, hey Harmony, what am I going to do with it? Where does it go?
The Z on the C-score.
Okay, so these things are Z-scores and their standard deviation. So you're right. We're going to plug that, negative 1.65 is equal to. Now, if we go back to our question, we know the mu, right? The mean is 4.8. So this is negative 4.8. And my sigma is 0.6. And then I guess I need a variable. So that's the x, that's the year. So sorry.
Yeah. Oh, thank you.
Sorry about that. The year we're looking for. And feel free to watch the videos I did by myself. I'm not moving stuff around nearly as much. All right, so we're going to solve this. And although I'm a fan of cross multiplying, it doesn't make sense. It's easier this way. Those are going to cancel out. So 0.6 times 1.65. So negative 0.99. So I multiplied this side is equal to sorry. Okay, I'll fess up. I was playing with my dog last night and I have messed up my arm, and that's why I'm uncoordinated today. That's what I am claiming. Jelly bean is too strong for me. X minus 4.8. Sorry, back to work. All right, so I need to solve for the X. Brad, what do I need to do? One step.
Oh, you divided it or take away that 4.8?
Oh, you're so close. You guessed wrong twice. I need to get rid of it. So how do I get rid of it? I'm not going to divide. I'm not going to
What do you
subtract.
add?
There we go. Add 4.8. So negative, whoops, how do I do that on here? Negative 0.99 plus 4.8. All right, so we get 3.81 is equal to my X. And that, my friends, is our answer. This would be years if you want units. Whoopsies. And that fits in there. So 3.8 is certainly between 3.6 and 4.2, which is what we were thinking before. Ta-da! All right, one last question. And then we're done.
I have one question, Joanne.
You bet.
Where did you get the negative 1.65 from?
All right. So, you're with me here?
Yeah.
Okay. And then I looked for that number on the table. So you have to look in the boxes for it when you have the percent.
Yeah, I got that one.
Okay. This was the closest that I got.
Yes.
So when I went this way,
Okay, I see.
the first two come from there, and the last one comes from up there.
Okay.
Cool, cool.
I see.
All right. Last question. And this might be a test question, or it might be a bonus test question. I can't remember, but it looks something like this. Let's say I give you the data and I tell you that 99.7% of the population is, oh, I don't even know what my data is between 75 pounds and okay, 99.7% of Labrador retrievers have a mass between 75 pounds and 115 pounds. What is the mean of the data? And B, what is the standard deviation? So this is your extra special treat for the exam tomorrow. Where do we start? Anybody got an idea? What else? Same thing I do all the time. Let's draw a chart. But this is messy. Well, okay, never mind. It's messy. But I don't know what to do next. I watch the cat. Yes, Harmony was watching your cat go through the screen. Okay, guys. Where's the mean in my picture? Anybody?
The 99.7%.
Okay, right. But in my picture here, we're going to get to the 99.7 in a sec. Where is the mean going to be?
In the middle.
In the middle. Oh. Okay, I'm just going to take a moment and apologize to Clarissa because my screen wasn't showing you and it wasn't showing me there was anybody else there. I'm not ignoring you. So if you think that my apologies. And same with Rachel. It usually shows me that there's more people, but it didn't. Okay, in the middle. Anyway, back to work here. So this, I don't know what it is, but it's in the middle. Does this look familiar to anybody? The 99.7. How much data is within one standard deviation of the mean? So if I colored in that stuff, Clarissa, what percent would that be?
The 99.7.
Not yet. What's 34 plus 34?
68.
All right. But we're not looking for 68. We're looking for 99.7. So what do you think we should do? How about, let's make it wider. If we include those pieces, Clarissa, can you add that up for me? I'm making up for a whole class by asking you everything.
It's 95%.
All right, are we getting closer?
Yeah.
Are we there?
No.
All right. How about now?
It's 99.7.
Woohoo! All right. Thank you. So if 99, 0.7% of my population is there, who can tell me, maybe Clarissa, what number should I put down here?
75.
Nice. So then what goes here?
The 115.
Nice. How do we get the mean?
I don't know.
Okay. Somebody else want to jump in? Rachel, if you know these two numbers, how do you find the middle of just in general two numbers? Somebody help. Anybody?
You just add them.
And so,
Add and divide.
yes. Oh, you didn't see me just give up on that. 115 plus 75 should be 190. And then we're going to divide by 2, right? So that means 80 is our middle. So this number here is 80. Whoops, that'd be helpful if you could still see it.
Isn't that 95?
What? Thank you. I would have got there because the next step wouldn't have worked. Thanks.
You're welcome.
All right, get rid of that. Get rid of the evidence. So if I
You
really
guys
want
gotta
to,
wake up.
I gotta wake up. From here to here, okay, hold on. No, here's my picture again. We now know that this is 95. And we know that this one is 75. And that's 115. Now, 95 minus, that's 20 on that side, and 115 minus 95. Okay, so there's 20 there and 20 there. We need to figure out how far that is, and that, and that. Are all of those going to be the same size? Anybody?
Yes.
Yes, those are our standard deviations. So we know that 3 standard deviations is equal to, if I go 115 minus 95, I get 20. So if 3 standard deviations is 20, how much is 1? What am I going to do? Don't overthink this. Here, let me help. 3x is 20. Clarissa, what am I gonna do?
Wait, I'm confused. Where did you get the 3?
1 standard deviation,
Oh.
2 standard deviation, 3 standard deviations. And the 20 came from when I subtracted those two. Rena, how do I get X by itself?
Oh, yeah.
All right, whoopsies. 20 divided by 3 is 6.7. We'll just call it 6.7. So there's our standard deviation. So when you get a question that looks like this and it says a certain percent of the population is between these two numbers, start by drawing yourself a chart and figure out. And it's always going to work out from the center. It'll always be symmetrical. All right, that ended up being longer than I anticipated, but that's cool because we did a good review for math. Your math exam is tomorrow. So please do some study, do some practice, do the stats hand-ins. The second one, there's a bonus question at the end. And one of the numbers is 201. It's supposed to be 210 if you want to do the bonus question. So doing those practice sheets would be a good idea to get ready for it. Tomorrow morning we'll do some environmental science, but if you come in and say, hey, Joanne, can we please review this, or can you please explain something, we'll also take time out to do that. Anybody, hold on. I'm going to stop my recording.